Alright, welcome everybody. We're doing the Wednesday section of the homework for Term 3, Week 6. Let's get started. We're up to question 27, where it says, find the area of the circle below. Now firstly, let's just realise that's actually a semicircle. And look at the hint, it says, the formula for a full circle is a equals pi r squared. What is the formula for a semicircle? Now if you compare the full circle with a semicircle, you'd have to say that it's a full circle, which is pi r squared, divided by 2. When you now look at the semicircle, you've got to ask yourself, what's the size of the radius? Because in that formula there's an R, and R means radius. When I look at this, I'm thinking the radius is actually 2.5 centimetres. Right, so let's apply that formula now. So we're going to write pi times 2.5 squared, and all that's going to be divided by 2. So if you could pause now and work that out on your calculator and then come back and check your answer. Hopefully you've worked it out, because I've worked it out and I've got 9.8, and that would be centimetres squared because we're talking about area, and area is measured in squared. Alright, we're up to question 28 now, where it says find the circumference of the sector in question 28. Now just note that's a misprint. It obviously should be question 27. So let's get that fixed straight away. And the hint says, imagine you had to walk around the entire shape, how far would you travel? Noting that the circumference for a full circle is c equals 2 pi r. So here you are, pretend you're a little person standing there, and you're going to walk around that semicircle, and then you're going to walk along this straight edge back to the starting point. How far did you travel? Well, if you look what I've written down there, we've travelled around the curved part, and that's the full circumference divided by 2 because it's a semicircle. Then we've travelled along the straight edge, which is 5 centimetres. So we've come the full circle. And then we'll just pause our calculator there and we'll work it out. Okay, if you've hopefully calculated that, you should have got 12.85, and then there's lots of decimal values after that. We'll round it off. And let's go to 12.85, looks pretty good, and the units are in this case centimetres. So well done if you've got that, give yourself a tick like the last one. Now question 29 says we have to find the volume of a half cylinder with a diameter of 14, and its height is twice its diameter. Now that's a bit confusing, so we'll just read that carefully and we'll draw a picture because it'll help us to visualise and see what we have to do. So I'm going to draw my picture now. You might like to pause and try and draw your own picture of that information. Well, I've drawn my picture now, and notice I've done a standing upright. It's a bit messy, but it's a half cylinder. Now before we start to work this out, I've got to figure out what's the radius of this. Now we were told the diameter was 14, so the radius is actually going to be 7 centimetres because the radius is always half of the diameter. Now, the volume of a cylinder is normally given by pi r squared h. I'm going to use that, but remember because it's now a half of a cylinder, I'm going to divide the answer by 2. So let's write in, we've got pi times the radius squared. Now just look at it, the radius is 7. So pi times 7 squared times the height, which is 28, and all of that is going to be divided by 2. Pause it there and calculate that for me, please. Okay, you're back, and you get a fairly large number. It ends up being 2,155.13256. Now we weren't told how many decimal places or so to round that off, but let's make that about 2,155. And we'll use centimetres cubed because we're talking about volume, and volume is measured in centimetres cubed. Okay, we're up to question 30 now, where we have to convert each number to a percentage, and the hint says that we have to multiply by 100. So 0.3 times 100, that normally means we move the decimal point 2 places to the right, and if we were to do that, we would get 30%. Now 3/4 times 100, you might in your head think about what's 3/4 of 100, or you might calculate 3/4 times 100, and that would be 75%. That's a common one that you should know off by heart, hopefully. 0.34, once again, let's move that decimal point 2 places to the right, or figure it out on your calculator, but you should get 34%. And the next one's a pretty large number, so if we move the decimal point 2 places to the right, or use your calculator to multiply by 100, you get 171.7%, which is a fairly big amount. Alright, up to number 31 now, where it says we have to convert these to a simple fraction, and the hint says we have to put them over 100 and simplify if you can. So if I was to write 2 over 100, you would notice that can be a simpler fraction because 2 goes into the top and the bottom one time in the top, 50 on the bottom, and there's the number 1 over 50. Now we get to 2.3 over 100. We don't normally like to have decimals on the top of a fraction. We prefer to write the simplest form using whole numbers. So the trick here is we're going to move that decimal point one place to the right, but if you do that on the bottom, you've got to take that imaginary decimal point and move that one place to the right. And what you're going to end up with is, I'll just write it over here, is 23 over 1000. And that's the simplest version of that percentage. The next one's 23%, so I'm going to write 23 over 100, and you might notice that because 23 is called a prime number, it doesn't have any factors other than 1 in itself, so it can't be simplified with 100. The fourth and final, 234 over 100. You might think, how can I simplify that? Well, you can think of a number which divides into the top or the bottom, or you can grab your calculator and type that in as a fraction and press the equals button. And if you do that on your calculator, you end up with an answer of 117 over 50. Some of you may have written that differently. You might have written that as 2 and 17/50, which is also correct. Well done. Question 32 now. It says here we have to work out 17.5% of 81. On your calculator, if you own one of the Casios, you can press shift brackets to get the percent symbol up. So you can type in 17.5%, and where you have that percent symbol there, you can type in shift brackets. And we're going to type in times because the word of in math normally means times. So times 81. Please pause it and calculate that. You've worked that out, and I got 14.175, and that's in dollars. So you might round that off to be, say, $14.18 would be the best rounding for that one, because when it's 5 or above, you round up. Question 33. Kira got 560 out of 850 in a test. Gee, that sounds like a big test. The hint says, write a fraction and then multiply by 100. So let's write a fraction. 560 goes in the numerator position. 850 goes in the denominator, the bottom position. And then we're going to multiply by 100. So please pause that and figure that one out on your calculator. Okay, and when you've got the result, I've got 65.88%. You might round that off to the nearest whole number. You may have written 66%, which is about 2/3 of the question correct. Alright, what percentage is 520 metres out of 0.75 kilometres? Now think, are the units the same there? One's out of metres and one's out of kilometres. Now to do this properly, we really need them in the same unit. So I'm going to turn that 0.75 kilometres into how many metres? Well, there's normally 1,000 metres per kilometre. So if I multiply by 1,000, I'm going to get 750 metres. Okay, so now I've done that. I've got 520 metres out of 750 metres. Now I'm going to multiply by 100. Let's see what we've got. Pause it, figure it out please. Hopefully you've calculated that. I got 69.3 repeater percent. So let's leave it at that. That's perfectly correct. Alright, a bit of a tougher question now, 35. Holiday loading is a 17.5% bonus paid to staff during holiday periods. If Roger, but his nickname was Roger Dodger, has a wage of $7,285 for 4 weeks of holidays, notice the little misprint there, which is his normal pay plus holiday loading. How much is Roger paid normally per week? Okay, this is a really tricky question, so I'm going to talk you through it. If you got 17.5% on top of your normal wage, and your normal wage might be considered as, say, 100% of your normal wage, so you're getting 17.5% on top of that for your holiday pay, it's like you're getting 117.5% of your normal amount. And that's what Roger's got for his holidays, and he's got that for 4 weeks. So the first thing I'm going to do is say, what's $7,285 divided by 4, and that'll give us a 1 week amount. So do that now, please, and figure it out. You should have got $1,821, and if I can just fit it in, 25 cents there. So that's Roger's wage plus it's the holiday loading for 1 week. So it's like 117.5% of his normal amount. I'm going to write that down so it looks really clear. 117.5% represents his wage of $1,821.25. Now we're doing something called the unitary method. I'm going to pull this down to 1% of his wage. So I want you to think, how do I make 117.5 turn into a 1? Well, the trick is, you turn any number into 1, you divide it by itself. So I'm going to take 117.5 divided by itself, and that will equal 1%. Now if I do that on that left side of that equation I'm figuring out, I've also got to do it here. So I'm working out 1,821.25 divided by 117.5. So type that in and figure it out, please. If you've done that, I've come up with 15.5. So what we've worked out is 15.5 or $15.50 is 1% of Roger's normal wage. Now he's normally getting paid the equivalent of 100% per week, or 100% of his wage, that is. So how do I turn this 1% I figured out over here into 100% over here? Well, the trick is I'm going to multiply by 100, and sorry it's a bit messy. So if I'm doing that to turn the 1% into 100%, I've got to do the same with the $15.50. So I want you to type into your calculator 15.5 times 100 and then figure that one out. Now if you've done that, you should end up with $1,550 per week is the normal wage for Roger. That's a really tough question, so well done if you've been able to follow with that one, or if you worked it out on your own. Alright, we're up to the next question, which is question 36, a ratio, rates and scale drawing set of questions. So number 36, simplify the ratio of 3 to 27. The hint says simplify by dividing by the highest common factor. So look at the 3 and the 27 and think, is there a number which divides into 3 and also divides into 27? Now, if you've done that, the highest common factor there is actually 3. How many times does 3 go into the left side of the ratio? Once. How many times does 3 go into the right side of the ratio? 9 times. So the answer is 1 to 9 is a simple form of that ratio. Question 37 is the same, it's just a bit more difficult, and it has 3 ratio parts. So we're looking for a number that divides all of the terms by the highest common factor. So what is the term we're going to use there? We'll do a bit of, you might want to pause there and do a bit of calculating and maybe guess and check and try and figure that out. Back, you probably toyed around with trying to use the number 7, but you would have realised that that doesn't go into 164. Some of you might have even tried 14, but it also doesn't go into 164. Unfortunately, the biggest number we can use in this one is 2. So if I divide all those terms by 2, or ask, how many times does 2 go into each term? Well, the first term, 7. The second term, 2 goes in 21 times. The third term, 2 goes in, halve it, 82 times. That is the simplest ratio for that set of 3 numbers. We're up to question 38. We have to divide $400 in this ratio of 6 to 1 to 3. The hint says how many parts are in the ratio. Add them up and divide the amount to see how much each ratio part is worth. So looking at this ratio here, we've got 6 parts on the left, 1 part in the middle, plus 3 parts on the right. That makes a total of 10 ratio parts. Now, there's 10 ratio parts, and they have to make up a total of $400. Okay, you might be able to do that one pretty easily in your head and realise that 1 ratio part is actually represented by $40. Now, if I go back to my original ratio now, the person on the left has 6 parts, so that's 6 lots of $40. You might figure that out. It's $240. The person in the middle, or the number in the middle, has 1 ratio part, so that's obviously only $40. And the person on the right, that's represented by 3 parts, $3 $40. That's $120, and that's the answer to that question. Last question on this column. Lily rode 60 kilometres in 3 hours, travelling at a constant speed. What speed was she travelling at? Well, the hint is to look at this triangle over here. When we're trying to figure this out, we cover up the one we're trying to figure out, and that tells us that we have to use speed equals distance over time. So I'm going over here, I'm writing that, and the speed is 60 divided by 3. In this case, that's 20. And what are the units? Well, this distance was kilometres, the time was hours, so we call that kilometres per hour. And that's the end of the section. Hope you went really well and understood some things that you didn't understand last week. And as always, if you find an error, please let me know about it. Bye-bye.